my Earth. I got my moon. We'll call this a moon. So the Earth is orbiting this way. Okay, it's orbiting this way. It's 66,000 miles an hour. So when the moon is here, the moon's going around the Earth like this in the heliocentric model. So when it's right here, it's moving 66. Well, when it's right here, it's moving the same speed as the Earth to keep its same distance. To get to here, it's got to speed up. The moon's moving 2,000 miles an hour. That's what they tell us. So it's going 69,000 miles an hour. Here it's going 69,000 miles an hour. Now it's got to slow down to get behind the Earth again. So it's got to speed up and slow down and speed up and slow down to maintain its position. Most people's brains melt at this point because they're like, I can't figure that out. The reason you can't figure it out is because it's stupid. It's unfigure-outable. It's not real. People think that because they can't understand something, that means that they're stupid. No, it means that the thing you're trying to understand is stupid a lot of the time.
So the Earth, you don't think the Earth spins at all? It just is stationary.
The Earth does not move one bit. If it did, you would know it. I was just in a couple earthquakes in Acapulco. I knew when the Earth was moving. All right? We're not moving. People, well, you don't understand relative motion. There's no relative motion on a curve. Go in a car and at whatever speed, a nice fast speed. And if it takes the slightest turn, you feel it. That turn gives your body the sense of acceleration. The dinner plate with water. Watch the water. Right? Well, every motion of the Earth is a curved motion. Well, the Earth only spins one time a day. You can't even see an hour hand on a clock go around. And that's going twice as fast because it goes around twice. Yeah, but you're thinking of angular speed and not linear speed. A clock, if you have a 24-hour clock, let's start with a merry-go-round. A merry-go-round. If it went around once per day, it would really be hard to tell that it's moving, right? You're on a merry-go-round, boy, this is boring. And it would barely move, but, if you come back a couple hours later, you're like, oh, it did move. Now expand that out to 2,400 miles in circumference. So now it's moving 100 miles an hour. I think you'd notice that. Now expand it to 24,000 miles, the size of the Earth. Now it's going 1,000 miles an hour, and it's going off your trajectory at a mile a minute. A mile sideways. You don't think you're going to feel that? We can prove that you'll feel that.
If that's the truth, would the center be spinning really fast, like the North Pole? Like on a record player, would that be going really fast?
Well, it's going the outside. It's angular. When you're standing a mile from the North Pole on a ball, you're going in a circle. You're going in a circle, and you're only going 6.28 miles every 24 hours because that's the radius, right? But if you're on the equator, you're going 24,901 miles in that same period of time in just a bigger circle. So, yeah, well, it's going the same angular speed, but the linear speed is different every point on that ball. So there is no spinning. If we're spinning, we would know it.